Well, so the chapter is laws of motion, and we are continuing with this. And in the earlier discussions, we have discussed about the laws of motion, like first law, the second law, and the third law. And now we are coming towards the fundamental forces of nature. Now, the fundamental forces of nature, when we speak, we are referring to different type of forces in nature. However, this chapter is constituted of inclined planes, the pulley, then the lift moving up and coming down, the various types of concepts we have to discuss in this particular chapter. So, fundamental forces of nature, they are many reactions occurring in the nature. Behind each reaction, there is some interaction because of which the reaction takes place. Forces of different nature act in different reactions. Different forces or interactions can be divided in the following four fundamental forces on the basis of their nature. So these forces are gravitational forces, the electromagnetic forces, the nuclear forces, the weak forces. When we speak of the gravitational forces, these forces are mass dependent forces. Like the law of gravitation states that two bodies attract each other with a force which is directly proportional to the product of masses and inversely proportional to the square of distance. These forces are quite dominant among the planets and stars. Like Sun and Earth have mutual attraction, and Earth and Moon has mutual attraction. So regarding Sun and Earth, the attraction is mutual, but the direction of attraction that will be towards Sun. And similarly, in case of Earth and Moon, attraction is going on, but the attraction will be towards Earth. Moreover, the planets are revolving around the Sun. According to Kepler, these planets revolve in elliptical orbit. The shape of the orbit changes according to the size of orbit. So nearest planets will revolve in circular motion nearby, and the other planets will have more ellipticity. As we reach to the farthest planet, it will be extremely high ellipse, and such a ellipse which meet at infinity is known as asymptote. So gravitational forces are among the masses, and the law can be taken as F is equal to G m1 m2 divided by r square. That is what the gravitational force. Now, electromagnetic forces means the forces among the charges. So, electromagnetic force means either the charge is moving or it is stationary. If charge is moving, it has two fields. One is electric and other is magnetic. But if the charge is stationary, it has just one field, that is electric field. Now, whether it is electric field or magnetic field, we find that these fields exert force. So electromagnetic forces are generally known as the Coulomb forces, or the forces due to moving charges or stationary charges. Then we come to the nuclear forces. The nuclear forces are basically existing within the nucleus. So nuclear forces are charge independent forces. They are short range forces. They can be repulsive or attractive, that depend upon the critical distance among the nucleon pairs. There are three types of nucleon pairs: the proton-proton pair, that is called pp pair; the neutron-neutron pair, that is nn pair; then it is pn, proton-neutron pair, that is pn pair. So there are three types of nucleon pairs: pp, nn, and pn. If the separation among the nucleon pairs is 0.5 Fermi to 3.8 Fermi, their tendency is to attract, and nucleus will be dominated by attractive forces. And if the separation of the nucleons is more than 4 Fermi, the nuclear force drops to 0 and the nucleons will fly off. But if the nucleon separation is less than 0.5 Fermi, then it means that their tendency is to repel. So nuclear forces are of two types, the repulsive and attractive, depending upon the separation among the nucleon pairs. So the range of nuclear force is generally 0.5 to 3.8 Fermi, which in approximation is 1 Fermi to 4 Fermi. The weak forces are normally due to beta decay. That is when nucleus disintegrates. Either there will be emission of a positron or antineutrino. They are very, very weak forces. When neutron decays, it decays into a proton, a high energy electron, and neutrino. Whereas when proton decays, it disintegrates into a neutron, a positron, and antineutrino. Now, first of all, we will go through the gravitational forces. These are attractive, as I have explained earlier. This attractive force acts in between the two masses. This force can be determined by Newton's gravitation law. According to Newton's gravitation law, F is equal to G m1 m2 by r square into minus r. That is the vector form. But if it is to be written in scalar form, it can simply be written F is equal to G m1 m2 divided by r square, where m1 m2 are the masses and r is the distance among the masses. G is called the gravitational constant. Its value is 6.67 into 10 to the power minus 11 mks units. If we wanted to write this value in CGS, it should be 6.667 10 to the power minus 8 CGS units. This force acts in between the planets and its magnitude is very large. This I have already explained. This force also acts in between the atomic particles because atomic particles are having some mass, maybe very small mass. So the gravitational forces exist within the nucleus also, or among the protons and electrons, or electron pairs, or electron proton, or proton and proton, or proton and neutron. All of them have got the masses. So gravitational force is mass dependent force, and these all pairs have some critical separation, which is normally of the order of 10 to the power minus 15 meters. That is 1 Fermi. This force is weakest among all the forces in nature. Energy particle of force is graviton. This force is important in those circumstances in which one body taking part in interaction is having astronomical size. Obviously, the astronomical size are very large. The distance from center of sun to the center of earth is called astronomical distance. Its value is nearly 9.5 into 10 to the power 11 meters. So that is the astronomical size. The gravitational force for 1 kilogram mass will be 6.67 10 to the power minus 11 newtons acting between the two bodies, and each body has a mass of 1 kilogram and their separation is approximately 1 meter. So placed at a distance of 1 meter apart. The interaction time of the forces about nearly 1 over 100 seconds, that is 10 to the power minus 2 seconds. A force of the order of 10 to the power 20 Newton acts in between the moon and the earth, whereas the force of 4.05 into 10 to the power minus 47 Newtons act in between electron and proton of the hydrogen atom. Electron will be in the orbits, proton will be in the nucleus, and the distance between electron and proton is nearly 0.53 angstrom units. That is 5.3 10 to the power minus 11 meters. So by knowing all these things, we can use the formula F is equal to G m1 m2 over r square. Now we come towards the electromagnetic forces. So as I've explained you earlier, electromagnetic forces are working among the charges. So if the charges are moving, they constitute two fields. One is electric and other is magnetic. But if the charge is stationary, it will constitute only electric field. Normally, electromagnetic forces are governed by Coulomb's law, and the Coulomb law is F is equal to K Q1 Q2 over R square, where Q1 and Q2 are the charges, R is the distance among the charges, and K is electrical constant, whose value is 1 over 4 pi epsilon naught. So, as it is mentioned, the force acting between the stationary or the moving charges in the electromagnetic force. Source of electrical force are stationary and moving charges. Magnetic forces act only on moving charges. Now, these forces may be attractive or repulsive. There is a repulsive force between the charges if they are similar, and the forces will be attractive, that is the nature, similar charges, and the nature will be attractive force between the charges of dissimilar nature. We can briefly say that like charges repel and unlike charges attract. The Coulomb law is given by this function as it is explained earlier. K is electrical constant and its value is 1 over 4 pi epsilon naught. So Coulomb's law states that F is equal to K Q1 Q2 by R square. K is constant, which depends upon the nature of medium, and for vacuum the value of K is taken as 1 over 4 pi epsilon naught, and it is calculated as 9 into 10 to the power 9 Newton meters square per second square. Epsilon naught is called the absolute permittivity, and its value is about 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. So if we compute these values, the value of K comes to be 9 into 10 to the power 9 Newton meter square per Coulomb square. The range of this force is very large. Electromagnetic force is about 10 to the power 36 times more stronger than gravitational force.